So sorry about that. No idea what happened. So bear with me. We're going to reload. I'm going to re-invite Wayne. The internet gods are not with us today. So come back in. We'll give people a moment. Let me queue up that slide again. We're going to wait for Wayne. So thank you for your patience. We will restart from where we were. I'm going to get the slideshow ready to go for when Wayne comes back. Thanks so much, you guys. If you have a colleague, please look for your colleague. Make sure that they are getting back online. We will restart once Wayne gets here. So check for your colleagues, check for any coworkers or friends that you have re-invited. Make sure that they have the link. I can also, I think this is Wayne texting me. Yeah, so Paige was just texting me. Thank you, Paige. We're just going to come back in. So sorry, I have no idea, you guys, no clue. So bear with us. We will restart. Not just you, Ben. I see Ben came back. So we're ticking back up there. We'll give our presenter, Wayne, a moment to come back in. It's Friday the 13th somewhere, or the internet's unhappy with maybe this is our physical distancing, but socially we're together. So I've got the recording going. We're just going to wait for Wayne. Can you guys confirm in the chat box that you guys can see the PowerPoint? Just let me know that you can see my screen share in preparation for Wayne getting here. Can you see the testing techniques slide in my PowerPoint? Oh, I see Wayne. Was that Wayne? Yeah, Wayne, I'm going to make you a presenter again. 1 second. Oh, why did it make you an attendee? That makes no sense. 1 second. My gosh. On the fly. Oh, Wayne's coming back.
I'm back. Don't know what happened.
I have no idea either, believe me.
It's the internet gremlins. Okay. So and good. We're at the page where I want to be.
Can we wait maybe 1 minute, Wayne? I'm just seeing, I want to give a few more people a chance to come back in. The number's rising. So let's just hold on 30 seconds. Okay. Can somebody please confirm in the chat box that you can see the PowerPoint slide that says testing techniques with water droplets?
Were they all clicked out?
Oh, yeah. I have probably 18 text messages. Oh. So I have no idea. And it's like my life was flashing before my eyes because I got an email on my phone in my hand saying, thanks for hosting your webinar. And that only happens at the end. So I had a split second to realize what was going to happen. Oh, boy. Yeah. So your patience is appreciated. We'll start in 30 seconds.
Okay.
I still haven't had anybody confirm. Can you guys see the slideshow right now that Wayne and I can see? Because I need to reload that if you cannot see the slideshow. Anybody in my audience can see the slideshow, or do I need to reload? Wayne, you can see it?
I can see it, yes.
Okay. So those of you guys, if you have a colleague, please check with them. I'm going to frantically respond to these messages while Wayne continues. I think we'll get started because this is recording. So at least I can splice together the recordings, and I'm going to respond to these messages. So if any of you guys have a colleague, please let them know I am responding, but you should be able to invite them in from your portal. So help your colleagues out. I will answer these messages now. Go ahead, Wayne.
Okay. Thank you, Katie. Sorry about that little glitch there. But just finishing up with this particular slide, A little bit of static electricity can build up around the tip, causing the drops to become smaller, to constrict. How do you fix that? It's very easy. You get a clean cotton cloth or a clean paper towel and wipe around the tip, not over it, but around the tip, and that will discharge the static so you'll be able to get the correct size drop. Katie, can you advance it, please? Good. Here comes another very important one, because I even had a call about this morning. All of those reagents that you see on your screen, they're all phenol red, and they all measure pH in the range of 6.8 to 8.4 because that's what phenol red does. The problem is that all of those reagents and the tablets you see on the left are not interchangeable, even though they're called the same thing, because all of those are different strengths, because they're also designed for different sample sizes. So you could not interchange those reagents. Katie, could you advance one more, please? And then, yeah, that's right. That's good. So, one more. There you go. That's it. So, even within the same manufacturer, if a reagent is called the same thing, don't assume that it is the same thing. Katie, please advance. For example, hello, Taylor. We make 4 different phenol red reagents for our pool and spa side of our life. 4. The one that's on here is reagent number 14. That's designed to be used in a 5 milliliter sample size for our residential kits. Advance, please. Sorry for the coughing, guys. This reagent is probably the one you're more familiar with. Reagent number 4. It's used in the comparator block that has a 44 mil sample size for pH. And that's the one that Katie was showing on the screen earlier on. One more, please. For those of you who have ever used or ever seen our slide comparators, that phenol red is a completely different strength because the sample size is 11.5 mils. So they're all different strengths, including, if you can go to the next slide, please, Katie. The electronic colorimeter that we have, the phenol red reagent for the pH test, completely different. So my point is, even though it's called the same thing, don't assume it's going to do the same thing. I get the calls all the time. I went into a store to get reagent number 14. They said they ran out of it, but here's number 4. It's the same thing. It's not the same thing, okay? Get the right reagent for the right test, the right part number. If you're ever confused about it, just call us test kit manufacturers. We'll be able to walk you through it. Now, there is one exception. There always is an exception. There is one more exception. Katie, please. Oh, no, it's not on this one, but that's okay. The only keep this one up. The only exception is DPD. DPD reagents, whether they're the liquid reagents or the drop test, they're all interchangeable because DPD is made the same way by everybody. So in a pinch, if you absolutely had to, you could use Taylor DPD reagents in a Lamont kit, for example. Lamont DPD reagents in a Poolmaster kit or a Gardic kit. They're all interchangeable. That's the only exception. Here's something else as far as techniques that's really critically important, because I see this happen a lot, is that don't wait to match your colors or do the test unless the instructions tell you to. So for example, you go collect your sample to do a free chlorine test, and you add your 5 drops of 1 and your 5 drops of 2, and you cap it and invert it to mix, and you look at your watch and go, oh, it's lunchtime. Then put it down on the deck or a chair and walk away for half an hour to go eat lunch and come back. You think you're going to get the right answer? Absolutely not. Because in that particular case, DPD, again, is reacting with air, heat, and light, and it's going to darken and darken quickly. You're going to get a wrong answer. Now, there are some instructions, there are some tests that tell you specifically to wait a few minutes. One of them is a phosphate test. If you've ever done that one, it's in the instruction, it specifically says wait 2 minutes. for the reagents to what we call digest. In other words, mix and react with the parameter that it's testing for inside the test cell so that you do get the right color development. Another example is metals testing. If you've ever done a test for copper or for iron, the instructions specifically say wait X number of minutes. It's different for copper and iron before you start matching colors. Because if you match a color right away, it's either not going to be there or it's going to register a very low value, lower than what you think it is. So again, read the instructions, and if it tells you to wait a couple of minutes, wait a couple of minutes. Katie, please. If you're doing a drop test, and this happens a lot, if you're doing a drop test for, say, alkalinity or calcium hardness, and you're not 100% sure that you've reached the right end color, this happens particularly with a total alkalinity test, add one more drop of the titrant. In alkalinity's case, it's reagent number 9. If the color is unchanged, if you add that extra drop, then your endpoint is actually the drop before. If it keeps changing color, that means you haven't reached endpoint. Keep on going till it doesn't change color. This is called the endpoint plus 1 drop rule. This is kind of like a backup for you when you're doing a drop test to make sure that you've reached the correct endpoint. Now, some tests, the endpoint colors are not very, very subtle. They're more like bam in your face. If you've ever done a test for sodium chloride, you go from a brick red color to, you go from a milky yellowish color to a brick red color, boom, at the exact endpoint. It's like, whoa, where did this come from kind of deal. Whereas in some cases, the endpoint color is a little bit more subtle as it goes along. So again, if you're not quite sure, add that extra drop. If it didn't change color, you're good at the drop before. Next, please, Katie. Don't use contaminated or old reagents, okay? This is very important. Most liquid reagents are good for about 2 years. Test strips are also good for about 2 years. Some reagents have a slightly shorter shelf life. Those would be the ones in the solid brown bottles, like DPD number 2, reagent 871 for the drop test for chlorine, the silver nitrate for a salt test. Those reagents are called, they're halogens, but they're also oxidizers. So any reagent from any test kit manufacturer that's in a brown bottle is an oxidizer. So what does that mean for you? Well, you just have to be a little bit more conscious of environmental conditions and storage conditions, because storage is 99% shelf life. Common sense storage conditions. So you're talking about keeping it out of direct sunlight, putting the cap back on the bottle when you're done with it. I've gone into pool and spa stores. I remember we did this specifically in Florida a few years ago, to the stores that have in-store labs. And I've walked into locations where every cap was off of every bottle on that lab. And it had been like that for most of the day. It's like, do you really think you're going to get good answers from that? No, not really. So cap them back when you're done. Make sure you put the right cap back on the right bottle. That's important too. Most reagents will have some kind of a lot number on there. All the reagents will have a lot number on there that will tell us, the manufacturer, when the reagent was manufactured. In the States, there next to the lot number is an expiration date. In Canada, you won't see an expiration date. That's a WHMIS thing. But for the most part, 2 years. So for our friends up north, what I would suggest is when you get a new reagent, write the date that you got it on the label someplace that you'll be able to see, and figure about 2 years. But rotating inventory is just as critical too. Make sure that when you get new product in, you use what's up front first and put the new stuff in the back, and a simple rotation. But you can always tell too that a reagent's somehow been compromised is simply by looking at it. Most of the indicator solutions are pretty strong, healthy reagents, and it takes a lot for them to go bad. But you can tell something's gone bad by actually shaking the bottle. This is one time I tell you to shake it, and turning it upside down. If, for example, on a phenol red reagent, I know we're kind of harping on that one, but it's a good example. If you do that, and all of a sudden you see layers of color develop, like a layer of yellow or a layer of green, then the dyes are breaking down. The organic dyes are breaking down. It's time to get rid of it. If you start seeing clumps inside the bottle or little swirls of material, things of that nature, get rid of it. It's not going to be any good. The reagents that are in the brown bottle are oxidizers, as I mentioned before, and you can tell that they're going bad by the fact that they change color. These reagents should be clear, completely clear. If they come out of the bottle either pink or red, then that means they've oxidized out and they're no longer viable. You should not use them. But in any case, if you ever question a reagent's viability, always contact the manufacturer. We'll be able to help you figure out whether your reagent's still good or not. Katie, please. Now, I know some of you use test strips, and that's perfectly all right, but I like to bring up this picture because this is a technique issue. Take a look at this picture. This young lady who's doing a test in a pool using a test strip. What's wrong here? There are actually two things that are wrong with this picture. The first one is you might have noticed that the top of the box that's just past her right hand, the lid's open, exposing all the test strips in that box to air, heat, and light, which could make them degrade faster. The second thing that's wrong with this picture is that she's simply immersing the strip at the surface of the water. Remember earlier I told you need to go 18 inches down and away from return lines? Well, for those of you who use test strips, that holds true too. Collect a sample from 18 inches below. Excuse me, 18 inches below, and then use that to dip your test strip in. Don't do it on the surface. Katie, next slide, please. Here's another one, same young lady. There are two things wrong with this picture. And the first one is the same thing that was wrong in the previous slide. The cap is open on the container. You got to shut it when you take out that test strip. Again.
Perfect.
Katie, do you hear me?
Yeah, we hear you. Perfect. So let's do that.
Okay.
Just as loud as you can. It's a little distant.
So we'll start from this slide. Sorry about that, everyone. Okay. So again, with this particular picture, there are two things wrong. The cap on the container is open. But the other thing too is the background. You can see that the water has a blue shade because it's taking on the tint of the paint. But sometimes the background like that can affect somebody's ability to match colors. So the best thing to do is follow a certain procedure as far as placement whenever you're trying to do color matching. Katie, can you advance, please? There we go. So take a look at the lifeguard on the left-hand side. She is presenting the correct way to hold a color matching test. So you want it level with your eyes, perpendicular to the ground, and you want to face north. You see, if you look closely at the picture, the sunlight's hitting her on her shoulders. Okay, but the reason you want to face north is that you won't be facing directly into the sun. Because if you're facing the sun, it's going to alter how your eyes interpret colors. It's not going to change the color that you developed. It's going to just alter how your eyes match that colors. Also, in the picture on the right, if you wear sunglasses, please take them off. Because even the most inexpensive dollar store kind of sunglasses have a little bit of polarization to them. that could alter the spectrum that you're trying to see through, and you're going to get a wrong answer. This is particularly true if you're wearing those yellow tinted like driving sunglasses you might have seen. That they really mess up everything. Now the problem is if you're trying to do color matching and it's at night, what do you do? Well, you've got a couple options. The first one is that you want to try to get some kind of a daylight simulating lamp, much like the makeup mirrors you might see in department stores. These lights simulate natural daylight, and you could use those as your background light. If your budget doesn't allow for something like that, what you is basically be consistent in your inconsistency. And I know that sounds kind of funny, but get your sample, go to an office or away from the pool itself, and knowing that fluorescent lighting is going to alter also how your eyes interpret colors, do the test there, but do it in the same spot every time. Because that way you'll be consistent as far as the kind of light that's coming down. And hopefully you're good at color matching so that you won't have to have this major hassle. Now, the other thing, too, is that when it comes to color matching, most men have a kind of red-green color blindness. In other words, we can't see subtle shades of pink and red sometimes. And I have that problem myself. All the colors on our comparator block look the same for me for chlorine and bromine. So that's why I do the drop test, like Katie was mentioning earlier. Women have a problem with very subtle shades of yellow. And this is not Wayne talking or Taylor talking. These are ophthalmologic studies. So that's why, for example, those yellow-tinted driving glasses are so horrible when you're trying to match colors. It makes it very, very difficult. Next slide, please. There's the sunglasses, okay? So we can go ahead and advance one more. Okay, here's just a perfect example. On inside, underneath fluorescent lighting, those socks look to be the same color. But you go outside and nope, one's blue, one's black. And this happens to me an awful lot. This is why I wear brown socks most of the time. But it's very true. Depending upon your facility and whether it's indoors or outdoors, light is critical when you're trying to match colors. Go ahead and advance, please. Okay, swirl, shake, or invert, which is right. This goes back to, again, read the instructions. And I think I've mentioned this already. But, follow the instructions. Some will say swirl, some will say shake, some will say cap and invert. It kind of depends on which kind of test you're doing. So please follow the instructions. The one specific test that we tell people to absolutely shake is a cyanuric acid test. Okay, all the other ones, no. And now some of the industrial tests that we have require you to shake the sample or agitate it. But the only test in the pool and spa industry is that we tell you to shake it is cyanuric acid. So like a good boy or Girl Scout, we're always, be prepared. So we want to make sure that we do the right test. And we're going to prepare ourselves to do the right test, the next test. Along with that, I get questions a lot. What order do I do the tests in? There's no testing police here. You can do the tests in any order that you want. You don't have to do them in the order that comes in the kit. Now, common sense kind of plays into everything, and most of the people that I know will do a sanitizer and a pH test at the same time because you're filling up both vials of the comparator block at the same time. And that's perfectly fine. But, there's no set order. You can do them in any order you wish. Now, what I do suggest that if you're you're doing a test that requires some time, remember I talked about digestion earlier, is get those out of the way first, because they will take the longest amount of time. Then do the other ones. Next one, please. Now, this is not more of a testing thing, but this is more of a treatment thing, but it all ties in together. You should always wait one turnover to allow whatever treatment chemicals are added to actually mix through. And a turnover is anywhere from 6 to 8 hours, depending upon flow rate and number of gallons. But it takes that long. And tied in with this also is that you should never add 2 treatment products at the same time. Like I know some people add bicarb on one end, acid on the other. And no, don't do that. You're almost negating anything that you do. Do one at a time. Next slide, please. And this is an example of what not to do. Some of you who are CPOs should recognize this picture because it came straight from the manual. This is an example of how not to store your treatment. So for those of you who are involved in treatment, don't do this. You've got a 1,000-liter of probably sodium hypochlorite sitting behind a broken bag on top of what I hope to God is calcium chloride, not cal hypo, because cal hypo is hazardous in the sense that it is combustible. Now, in front of that, you have 2 small buckets of tabs with a gallon of algicide sitting on top. And on the left, you got larger buckets of tabs sitting in front of 2 blue carboys of acid. So this is just an explosion waiting to happen. You should always calcium hypochlorite. It is a combustible material when it comes into contact with organics. Next slide, please. Okay. Now, for those of you who might be using electronic testers, whether it's a full-blown colorimeter, a photometer, a little pocket tester for pH or something, okay, they have a little bit of a special technique. You got to make sure the glassware and the caps for the glassware are cleaned and rinsed between tests, and let them air dry. Don't wipe it down with a cloth. When you're dealing with a colorimeter or a photometer, there are arrows on the unit that will tell you how to position the test cell correctly. And depending upon the test that you're doing, you want to use a single sample cell. Use any kind of error that might happen. And make sure that you're doing the right test. There is a big difference between Ca and CaCO3. Ca is simply calcium. CaCO3 is calcium carbonate, okay, which is different. So when you're scrolling down to pick the test, make sure you select the right one. That's a common error when people are dealing with colorimeters and photometers. Next slide, please. Now, the next few slides are pictures of, again, of accidents almost waiting to happen. And I know that obviously many of you don't transport treatment products and test kits. But take a look at where this test kit is sitting on top of that bucket of tabs. This was actually in a parking lot at a Home Depot out in Santa Clara, California, that I took probably 4 or 5 years ago. Again, I hope to God this truck doesn't get into an accident, because if the lid pops open and mixes with some of the other treatment products, you've got a truck going on. If you go to the next slide, please, Katie. Now, thank God, this white powder you see on the truck bed is not. Had it been cal hypo, you would have seen the next picture. That is cal hypo that spilled and the back and the bed of the truck caught on fire. It's very dangerous. You got to keep them separated and solid. In other words, not moving around. The picture on the right is from a store in Texas where they just got a shipment of product, and just look how haphazard that pallet is loaded. I mean, that again is an accident waiting to happen. Just look how poorly it's shrink wrapped, and any kind of jostling or bumping could cause those bottles on the top to fall over and spill. Okay, big problem. Next slide, please. An example of something that I thought was really neat. I saw this in Florida. I believe it was in the Tampa area. This guy actually cut out holes in inch-thick plywood and places his tubs inside the holes, and it's like a negative fit, so it doesn't jostle around. I thought this was an excellent idea, but something to think about. Next slide, please. And Katie, that's it for today. Finally. So I'll be here to answer any questions you might have come up.
Oh, I think we need a drink, Wayne. That's I'm frantically trying to address all the emails and Facebook comments, and understandably, people are very frustrated. And I thank you, 48 people who are still here of the 180 people. So I think what happened in the last iteration was the room locked itself when we all left, and I never lock the room, right? If you come 5 minutes late, 20 minutes late, there's still benefit. I've been late before to meetings. I never locked the room, and I kept getting these messages saying, we're locked. And then what happened when I went to unlock the room, that's when it precipitated the Wayne echo. So thank you, everyone, for your patience. Thank you to Wayne, a great actor. Wayne does a lot of theater, so he's used to adapting on the fly. And so now we can say, we've done a video call on Mozilla and Chrome and phone. So you guys know, I'm just, for posterity, this is being recorded. I will splice it and I will put it up on YouTube tomorrow, Saturday, end of day. The show notes are in the chat box. I want to say a big thank you to Wayne Ivasich from Taylor Technologies, located near Baltimore, Maryland. They make the different water testing products. A super informative PowerPoint presentation. Those slides are available on the show notes page, as well as you will see access to different webinar recordings of other sessions that he has done and will continue to do for free, sponsored by his employer, Taylor. So if you're interested in additional webinars with Wayne and no tech issues, I assume, on his platform, you can go to the show notes page, scroll down, and see the various webinars that he offers. So Wayne, could you maybe quickly talk about the topics that you've selected for your webinar series and which sessions qualify participants for the free certificate of completion, whether it takes them a couple sessions or what that looks like?
Yeah, absolutely. I give 9 webinars on Tuesday afternoons from 3 to about 3:45 in the afternoon, East Coast time in the States. And again, like Katie said, it's free. And if you attend 4 of the core webinars, you get a printed certificate of completion from us. And the core webinars are hot water chemistry, sanitation and oxidation, water balance, and the one you saw today, testing techniques. And the other ones are on phosphates and nitrates, shelf life, other minor categories, but they're all available. And Katie, I don't know if you can do it, but if you advance one more slide, my contact information is up there. And if you're interested, there you go. And if you're interested in the next round of webinars, which will be starting in 3 weeks, just pop me an email, and I'll send you the links to attend. It's all which hopefully won't have these problems that we're having today. I only have 100 seats available per webinar, and they've been filling up pretty quick. So if you're interested, send me your email. I'll send you out the links, and we can get you hooked up that way.
The links, I did also put them on the show notes. So those of you that are still on this webinar, you can click on the show notes that are pinned in the chat box and you can immediately register. I believe Wayne uses GoToMeeting. So again, my apologies. I have no idea what happened software-wise today. This is not, I mean, I've done probably 12 or 14 webinars in the last week on Click Meeting. No issues, but I will follow up with them. Do we have any questions in the audience, water testing, whether it's a specific question that you have, anything you've experienced? I will re-put them in the show notes, republish them. The frequently asked questions website on the Taylor page is wonderful in terms of interference, in terms of different colors that people might see. The technical support page is really excellent. I will also share the video library that Taylor Technologies has on their website as well as on YouTube. Is a great resource for training staff, for understanding how to use the equipment that you've purchased.
Yeah, I see that.
Yeah, please.
Christine asks, right. They're every Tuesday from 3 to about 3:45 p.m. East Coast time.
Yeah, so that's about 1 p.m. in Mountain, 12 o'clock in Pacific, Arizona. Yeah, so it's about it's the same length as what he delivered today. So I asked him to deliver on a topic that is interference or problems, because if we're thinking about our lifeguards doing our water testing for us as pool operators, facility managers, and programmers, we take for granted that they know what they're doing and they haven't necessarily been trained. And then we jump on the results that they get. Oh, our chlorine is low. Oh, our pH is high. And we make changes that have a snowball effect on our operational quality when maybe the test was wrong. The other thing, Wayne, if you could briefly talk about my favorite, the R007 technique for high chlorine interference.
Well, yeah, a lot of times when you do a pH test, you get a purple color. Yeah, and it looks almost like grape Kool-Aid. And you mistakenly say, well, my pH is 8, and it's not. Okay, so what you do is you dump out that treated sample, rinse out everything, get a new sample. Add 1 drop of that reagent number 7. That's thiosulfate, which is a chlorine neutralizer. Add 1 drop, mix it around, do the test normally, 5 drops of number 4, and then match your color. And it's very, very important you only add 1 drop of number 7, because the pH of number 7 is high. It's 9.6. 1 drop in that sample size is fine. 2 drops will actually change the pH of your sample, and you're going to get a false high reading. Right.
Perfect. Yeah, and really, I would encourage you guys to check out the Taylor website. They also on their Facebook page, which I'll share in the chat box. Tori, the social media lady, she does amazing graphics with Wayne in terms of addressing what are frequent questions. So Wayne, he's personally answering questions and phone calls from people out in the field, troubleshooting. She takes that information and creates some amazing graphics. I've shared some of them on our Facebook page, the Lakeview Aquatic Consultants, last night and today, but I would encourage you to follow them on Facebook as well as on Instagram. They're doing a giveaway this week if you're interested in winning one of the hats. Other questions? Well, we've got Wayne online. We're all ready to go start drinking. It's early. We have another, Wayne and I have another webinar. Yeah, true. Wayne and I have another webinar in half an hour for a different matter that will probably involve some refreshments. So thank you to those of you that came back in. Thank you to those of you that were patient and able to get in. Please reach out to your colleagues. Let them know that we didn't have a party without them. We did still continue to have tech issues. I will splice the YouTube as best as I can. The video. I will upload it on YouTube. You can look for this tomorrow at Saturday, end of day. And if you'd like to attend this session again in the future with Wayne without the tech issues, go to the show notes for a future session or go to the Taylor Technologies webinar resource page, also on the show notes, and you can see some recordings. Okay. Last chance for questions. Again, I want to say thank you to Wayne, Taylor Technologies. Any other questions? Last call. I see a couple typing. Thank you, Marcy, for a good weekend. Thank you, everybody who's here. I see people are leaving. I get that. It's Friday. So thank you for joining us. Have a great weekend. Monday next week, we have Adrian Spencer talking about accessibility. Wednesday, we have Paul Macias talking about Instagram and aquatics. Friday next week, we have Tim Auerhahn from the Aquatic Council talking summer startup. I know that sounds impossible to believe, but thinking about how, whether your pool opens this summer or not, can you revise your summer startup lists, your checklists, your planning, your policies? We'll chat a lot about these again on Monday in the show, in the pre-show. So have a great weekend. Be kind to yourself. We'll see you again next week. And thank you so much for your patience. Bye-bye.